So in this question, we're told that the variable x is normally distributed with mean, mu, and standard deviation sigma. We're not given any other information about these two parameters, but we are told that the probability that x is greater than mu plus a is going to be 0.25. So let's start by putting that on a diagram and seeing what we can deduce from there. So the distribution uses the standard parameters. I know that the mean is going to be right here in the middle. Mu plus a must be on the right hand side since a is a positive constant and the probability of being above there is 0.2. So I just represented that on a diagram. The first question I'm asked is to find the probability that x is greater than mu minus a. Luckily, we recall that the very first thing we knew about the normal distribution is that it's symmetrical. So making use of its symmetrical properties, we can say that the probability that x is below mu minus a is going to be 0.2, which instantly lets me know the probability that it's above is going to be 0.8. So making use of the diagram and the fact that the normal distribution is symmetrical. The next question says the probability that the modulus of x minus mu is less than a. That's what we need to try and find. Okay, when dealing with the modulus, we need to consider both the positive instance and the negative instance. So I'll write each of those out and see what we can deduce from there. So for the positive version, the probability that x minus mu is less than a. For the negative version, the probability that negative x minus mu is less than a. Okay, for the positive one, just a little bit of quick rearranging. It's the probability that x, let's isolate x, probability that x is less than mu plus a. Okay, that's easy enough to work with. For the negative version, I'm going to first expand that bracket, so I'll get negative x plus mu, and now I'm going to once again try to isolate the x. Okay, so I've got mu minus a is less than x, and looking at these two, I realize that actually I can now merge these together and write them as one probability statement. X is less than mu plus a, x is also greater than mu minus a. So writing that all as one. Looking at the diagram, I realize that I'm looking for 0.6, 60%. Part C of the question, we're looking for the probability that x is less than mu plus a, given that x is greater than mu minus a. Okay, so this is quite tricky that there's no numbers involved, but we're making really good use of the diagram we started with. We already know with conditional probability, let's consider the conditional part, that x is greater than mu minus a. So just, here's another diagram. X is greater than mu minus a is everywhere to the right of here. So if I'm initially considering this shaded region, what is the probability that from there I get x being less than mu plus a? So let's see if we can represent that. That's going to be everything here. Okay, so what's the probability that we get the blue region given we're only interested in the green region? Firstly, we need the intersection of the two of them, and the intersection is shaded in blue. It's the probability that x is in between m minus a and m plus a. Luckily, we'd already found that probability. And that's going to be all over the given part. It's going to be all over the green section. The probability that x is greater than mu minus a. Once again, we'd found that probability as well. From that, we get 0.6 over 0.8, which is 0.75. So, a question which very much relied on a diagram, thinking about symmetry, thinking about conditional probability, and reducing our initial field of interest, and from there following through to get our answers.